Tonight you're going to learn about postulates 1 through 11. What I would suggest that you do, because I wrote out everything ahead of time, is pause the video and just write down the notes. And there's more pages to the notes, so what you're going to have to do is pause it, play it, listen to it, pause it for the next page. But I would suggest doing that so you're not writing while I'm talking. Okay, postulates. We already learned 4 postulates. So we learned the ruler postulate, the segment addition postulate, the protractor postulate, and angle addition postulate. Now we're moving on to some more postulates, but these are just numbered. They don't really have names. We just call it postulate 5. So through any 2 points there exists exactly one line. Well, that makes sense. If you have 2 points and you put a line through it, you can't put another line through it again because it would be the same line. Sure, you could put a line going through B, but it's not going through both points again. So for any 2 points, you only have one line. That's the first, number 5 postulate. Postulate number 6. A line contains at least 2 points. This is common sense. If you have 2 points, you can make a line. You could have more, that's why they say at least. But you can't make a line with just 1 point. That's just a point, a dot. So that doesn't work. So postulate 6, a line has 2 points. Let's move on to postulate 7. If 2 lines intersect, then their intersection is exactly 1 point. So in this example that I have here, you have AB intersecting CD, and it makes the point M. And I just made up those letters. There's nothing to say that you have to say M for intersection. But in this case, M is the point of intersection. These 2 lines can't intersect again. They can't create any more points because they're straight lines. If they bend down, then yeah, they would do 2. But these are straight lines, so they only intersect at 1 point. Postulate 8. Through any 3 non-collinear points, there exists exactly 1 plane. So I drew a plane, and then I put 3 points in it. A plane needs more than 2 points. If you just had 2 points, you couldn't create that plane. A plane is made up of several points, more than 2. 2 points only make a line, not a plane. Postulate 9. A plane contains at least 3 non-collinear points. So this relates basically back to postulate, 8, change that to an 8, because, let me see if I can change it, there we go. It relates back because they're talking about a plane and the points. In this case, a plane needs to have at least 3 points to become flat. If you have 2 points, it makes a line once again. Postulate 10. If 2 points lie in a plane, then the line containing them lies in the plane. So let's say you have a flat area, you draw 2 dots, you put a line through it, that line is going to be on that flat area. So it makes sense. The points that are in a plane make a line in a plane. And the last postulate we'll look at is postulate 11. If 2 planes intersect, then their intersection is a line. So for example, we have 1 plane going through, and we have another plane going through. Yeah, they have AB here, but it's a bunch of dots, a bunch of points that those 2 intersect at. So line AB is the intersection point. And that's all you need to know. Make sure that you have your cards ready to go. Just cut them out that you got off the Quizlet. And we'll start learning our postulates because it's important to learn those because we'll start doing something called proofs. And you need to have your postulates down if you want to do proofs. Okay, have a good night. Bye.